Alrighty folks, good day. We're talking about exponents today. We're talking about the parts of an exponent, what goes into calculating the value of an exponent, and also being able to write an exponent many different ways. One of the objectives of this video is for you to write it not only in the exponential notation, but also to write it in what I like to call an expanded form. That would be what's usually called the product of factors, and that's just kind of like a long way of writing the multiplication out that an exponent denotes. And also I like you to be able to calculate the value of a given exponent. Usually the single digit ones are fairly easy to figure out, but if you need a calculator to back you up in some of the bigger calculations, feel free, unless your teacher says no. Alright, so a power and a base are what we see in an exponent. The base is what that big number is usually in an exponent, and it tells us what number I'm going to use in multiplication. What am I going to multiply? Well, I'm going to use a bunch of bases, and I'm going to use the number of bases that the power says to use. I like to think that the power has the power in an exponent because it tells the base what to do. It tells the base how many to use. And since we're talking about exponents, I like to say that in an exponent, we multiply. It's right there in the word. So an exponent tells us to multiply. We know what the parts are. Hopefully you write that down if you get a chance. If you take a look at some of the examples here, and hopefully you can see them. If you can't, let me know. I think you can see them. Let's double check that. I think you can see that. That's fine. Alright, 6 to the second power, which can also be called 6 squared, and we'll discuss that in another video. That's written in that expanded notation, 6 times 6, and it's also equal to 36. If we take a look at 5 cubed, or 5 to the third power, that's how we pronounce these. 5 to the third power, that's why we call that a power. It's 5 times 5 times 5, and that equals 125. And when we see 10 to the fifth power, we have a base of 10 and we have a power of 5. I'm going to let you figure that out yourself, and I hope that you'll come to class and share that answer with the rest of the class and with me, so I can see that you've been paying attention, and if you've watched the video. If you tell me what the answer to this is, I'll give you 5 points on your next classwork assignment. Let's move on to another board. There's a lot of notes on this next board, so I would tell you to pause, take your time, expand the video if you can, if you need to see it a little better, and here we go. I'm not going to drop this on me. Okay, I didn't drop it on me. Woohoo! Like I said, there's a lot of stuff here. So we'll start here with this first panel. It says 4 to the second power. Again, we're going to read it with the base and then the power. 4 to the second power, or 4 squared. And the reason why we call it squared is because it's a geometric reference. We want you to think geometrically, that when we're trying to find the area of a square, we multiply a side length times a side length. And you see that here and here. So when I find the area of a square, I'm doing just that, side times side. Those are two equal numbers, and it's just a reminiscent of a geometric reference there. It's the same thing with a cubed value, which would be to the third power. 10 to the third power would be pronounced 10 cubed, and it reminds us of the volume of a cube, the volume of a rectangular prism, we like to say as well. We are finding volume by multiplying the length times the width times the height. Those are 3 dimensions. 3 dimensions here, we have 2 dimensions here. Again, pause if you need to, jot down stuff, and I'm going to get to all this. So, when we talk about powers of 10, those are exponents that have a base of 10 and then a power attached to them. And you'll see that there's a pattern associated with those powers of 10. And I say very often that math is about patterns and opposites, and if you can recognize both of those in a variety of situations, you have a pretty decent understanding of math. 10 to the fourth power can be written out like this, and the answer is 10,000. If I were to multiply in a calculator or by hand and pencil, 10 times 10 times 10 times 10, I will get the product of 10,000. 10 to the third, 10 to the second, or 10 squared, 10 to the first, and then 10 to the 0 power. It's kind of weird how they kind of whittle themselves down from having 4 zeros to 3 zeros to 2 zeros to 1 zero to no zeros. And that's the trick. The power in a power of 10 tells us how many zeros to use in that evaluated answer. And you can see that this one's kind of strange. It has no zero. It's just 1. That's actually a rule that we will follow. Any number to the 0 power equals just 1. And hopefully you'll remember that, because they like to throw those on tests quite often. Hint, hint. Hint, the power tells us how many zeros to use. So make sure you're writing these things down. Whenever we have a first power exponent right here, the first power exponent always equals the base that you're using. So 6 to the first power is going to be 6. 10 to the first power is going to be 10. A million to the first power is going to be, exactly, 5 to the first power is going to be 5. So these are valid as well. And again, 0 power exponents, I try to draw a 0 here. Not bad, not bad. And they always equal 1. 6 to the 0 power, 13 to the 0 power, 10 to the 0 power, 100,000 to the 0 power, they always equal 1. Okay? There are a lot of notes here, and I encourage you to take your time. I encourage you to rewind. I encourage you to ask questions, and I encourage you to bring your questions to class. Let's talk about them, let's discuss them, and let's learn on a higher level. Have a great day. Stay tuned for the next video. There's another video right after this.